My name is Matt Bongers, and I'm a product developer here at the Medical Materials and Technologies Division of 3M. I'm here today with my colleague, Carol Sedlock, to discuss some of the factors which can impact skin adhesion. Use of wearable medical devices as point-of-care diagnostics is a rapidly growing area. Devices used for monitoring vital signs, drug delivery, analyte sensing, and more are commonly attached to the skin with a pressure-sensitive adhesive. The stick-to-skin adhesive is often overlooked in device development, but there are many skin factors which impact adhesion, which should be considered in your choice of adhesive and skin preparation method. Here's a brief overview of some of the skin properties that affect adhesion, which we will be discussing in today's presentation. Careful consideration of each of these aspects is essential to proper device adhesion. We will begin by discussing some of the common contaminants of the skin surface and recommended skin preparation methods. Skin is naturally covered with an oil called sebum, which is excreted naturally from the skin. Additionally, the skin can often be contaminated with lotions, bacteria, oil from external sources, dirt, or hair. In order to achieve ideal adhesion, the surface of the skin should be cleaned prior to adhesive application. You can be tempted to use alcohol to remove oil from the skin, but soap and water followed by a thorough drying is recommended, as alcohol can excessively dry and even damage the skin. Additionally, clipping hair is recommended when possible to maximize the surface area which is available for adhesive contact. Thank you. I'm now going to pass it off to my colleague Carol Sedlock to talk a bit about skin breathability.
Thanks, Matt. My name is Carol Sedlock, and I'm an application engineer at 3M working with stick-to-skin adhesives and wearable devices. I will be discussing some skin properties that may not be as apparent as contamination, yet they play a critical role in adhesion. Let's start with breathability. Our skin needs to breathe to remain healthy. Human skin at rest has a moisture vapor transmission rate of roughly 200 to 400 grams per square meter per day. If you're working out and sweating, this rate can dramatically increase. Applying a tape which has a moisture vapor transmission rate lower than skin can hinder its ability to release moisture. Excessive moisture buildup under the adhesive can lead to discomfort, such as itching, and can also lead to more serious issues such as maceration. Choosing a breathable adhesive backing is the best option to maintain healthy skin. Another factor to consider is skin sensitivity. Acrylate adhesives are very tacky, which makes them great for increased bond and holding power. However, removing acrylic adhesives can pull on the skin and even remove skin cells. This makes acrylate adhesives less than ideal for some sensitive skin applications in which the user is an infant or elderly, or if the location is on the face or other sensitive area on the body. An alternative option in these cases is to use a silicone adhesive. Silicone adhesives will remove fewer skin cells, are less painful to remove, making them ideal candidates for sensitive skin applications or in use with a device which will be removed and reapplied multiple times. Another factor to consider is the cell renewal cycle. The stratum corneum is a layer of dead skin cells at the outermost surface of your skin. Our skin is continually shedding this layer and replacing it with new cells. On average, the skin is shed and replaced every 14 days. This amounts to approximately 9 pounds of skin cells per year. However, this cycle of cell renewal will reduce with age, along with other effects such as reduced moisturization leading to dry skin and thinning of the skin resulting in sensitivity. It's important to know that adhering to skin is not like adhering to static substrates such as glass, polymers, or metal. Skin is a dynamic organ which is continuously changing throughout the course of the device wear time. Another factor not so apparent is that skin has exceptionally low surface energy, which makes it inherently difficult to stick to. When bench testing adhesives that will be used on skin, avoid testing on substrates like stainless steel, which has a very high surface energy, as this will give an inaccurate portrayal of how the adhesive will perform on skin. Instead, use a low surface energy substrate such as low density polyethylene. It should be understood, however, that there is no perfect substrate which exactly matches human skin or the diversity found in our human population. For this reason, clinical testing on human subjects is recommended. Clinical testing can also help capture the wide range of various skin types throughout the world. Thank you. Now I'm going to hand it back to my colleague, Matt.
One final factor to consider is elasticity. The skin is a very elastic substrate which can vary based on location of the body. Choosing an adhesive backing which can stretch with the skin is essential to minimizing shear forces. When the skin stretches but the tape backing is not elastic enough to stretch with it, shear forces can cause the adhesive to delaminate from the skin. This is more common when adhering close to areas such as the elbow, hand, or other areas which can move or bend. In summary, remember to consider the age and most common skin condition of the intended user, the location on the body, and wear time when selecting the correct adhesive. Additionally, remember to choose a tape backing that will allow the skin to breathe, choose low surface energy substrates to model the adhesive in lab testing, and choose soap and water over alcohol to prepare the skin before application. Considering these factors which impact skin adhesion will help to ensure that your device has the best adhesion possible so you can focus more on device function. Don't forget to contact your 3M representative with any questions or for more information on any of these topics.